So Kirchhoff's circuit laws focus on telling us a few things about series and parallel circuits. It tells us that in a series circuit, the current is the same everywhere. That's why when we have an ammeter measuring current, it can be in series with it, because it's all the same. The current's the same whenever it's in series. However, the voltage is different at every individual object. That's why in older strands of Christmas tree lights, you might notice that the first ones are brighter than the ones at the end, because the current's the same, but they're getting less voltage, because like the first light bulb's using its amount, and then there's less for the second and less for the third, and so on. Also, you'll see that resistance, the equivalent resistance for the entire circuit, is the sum of all the individual resistors. So that means that it is larger than any individual resistance. And we're given a few equations, and if you look at your equation card, I've separated them into series and parallel circuit sections so that you don't get confused. If we read this problem, we've got three 25 ohm resistors connected in series. So we know that resistance A, and because they're all 25, we could say equals resistance B, resistance of resistor A, equals the resistance of resistor B, equals the resistance of resistor C, equals 25 ohms. And they're connected across a 120 volt power outlet. And so this is the voltage of the source, and I'm just going to put S there for source. Because remember, in a series circuit, the voltage of the source is not the same as the voltage at resistor A, or B, or C. And we're asked to find the equivalent resistance of the circuit. So if we look at our equations, we see that for a series circuit, the equivalent resistance is A plus B plus C. So we can see that it would be 75 ohms. 25 plus 25 plus 25, or you could just do 25 times 3. And then we're asked, what is the current in the circuit? And we can always use Ohm's law. And in these problems, we can use Ohm's law in two ways. But we just have to think about what we're talking about. If we're talking about one object, one resistor, we are talking about the resistor of object A, and the voltage drop at object A, and the current at object A. But in a series circuit, remember that the current at object A is the same as the current as B, is the same as the total current. So that one doesn't change. In this particular case, we're going to use it to talk about the entire circuit, which means we're talking about the resistance in the entire circuit and the voltage for the entire circuit at the source, and the current for the entire circuit. So when we plug into this and we want to solve for current, we know that we'll do V source divided by equivalent resistance, because we're talking about the whole thing, so we have to talk about the whole voltage and the whole resistance. And that is the number one place where people make a mistake here. They get confused about individual versus entire circuit. So make sure you think about it and make notes very clearly about what you're talking about. When we round this to two significant figures, we get 1.6 amps. We get 1.6 amps. Try the practice problems and let me know if you have questions.